I'm Bill Clark. I'm an engineer who's been at Riot for about 4 years. I spent a decent chunk of that time on content efficiency dealing with tech debt. And then I have continued to work on that a lot on Champion's team. And so I have almost 4 years of attempting to combat tech debt at Riot, and I'm going to share some of my thoughts from that. So there's a base level assumption that this talk is based upon, which is that shit happens. And what I'm referring to particularly here is shitty code happens. There are all kinds of to-dos all over our code base that are talking about, how we're going to fix this, how we're going to make this thing work better, or, the data more sustainable or more shared code or whatever. And that's just a price of doing business. So what is tech debt really? Well, it's a consequence of our tech choices. Ultimately, we need to ship products, we need to meet deadlines, we need to make compromises and have systems that are fundamentally incompatible in one way or another, and so we need to make choices that ultimately lead to problems. Ultimately, tech debt matters because it can hamper future development. It can either leave bugs in place or make it harder to reason about what's happening in the code or harder to make new code. And ultimately, it remains because there's a non-zero cost to fix it. Otherwise, you would go and just fix it all. So the key takeaways from this talk are, first of all, I'm going to give you some metrics with which you can evaluate tech debt. And then 4 broad categories of tech debt that I've seen over the course of my time at Riot. And finally, hopefully, I convince you that the 4th category, data debt, is in fact the worst category of tech debt. So that's my goal, because I hate data debt. So let's talk about those metrics. The first metric is the product impact of this tech debt. So this could be bugs that exist because of it, or it could be features that ultimately are not or cannot be developed because of the existence of it. The second one is the dev speed impact. This is on content creators or on engineers. How much slower are we at creating things because of the tech debt? Contagion is one that I'm very passionate about. This is how likely is it for that debt to spread out and inflict other systems and become that much harder to root out in the future. Then there is the raw fix time of how long would it take an engineer sitting at their desk to type out a fix to it. And surprisingly orthogonal to that is the fix risk. Sometimes fixing something can be 2 lines of code that you cannot ship because you have no idea what the implications of fixing it actually are. And so those actually wind up being 2 separate things, even though they might seem like they're actually the same thing. So now I'm going to talk to you about the 4 different types of tech debt that I've observed. So the first one is local debt. At a high level, local debt is basically you've got some black box in which bad things happen. And ultimately, it is local because outside of that box, nobody cares about how horrific things are inside of it. It mostly works. You've got maybe a stable API that isolates that debt from the rest of the system. So some examples of this from the real world are, for example, in the visual system, your eye perceives things upside down, and in particular, kind of dumb, is the fact that the retinal nerve blocks off some section of the middle of where the retina should be able to see, so you have a blind spot in the middle of your vision. However, your brain, immediately upon receiving the signal, corrects for both of those things, and the rest of the brain doesn't care. It's as if you can see all of the things right side up without that blind spot. And so that's local debt of the rest of the system doesn't care. There is some funky stuff going on inside of that little space. Similarly, if this was one of our server rooms, it'd be a problem if you had to go in there and make a change or debug what's going on. But if that server room just happens to work, who cares? It's full of horrible things, but if it continues to work, nobody needs to know that it's full of horrible things. So some examples of what I've seen of this in League of Legends, since that's where I've spent all my time working here at Riot, includes that Jarvan's R used to be made out of minions. And so you'd have bugs like this where Swain could walk between the minions if he got very lucky. And so ultimately, the bug here only affected Jarvan's R. It was not particularly contagious because it wasn't being spread out to all kinds of other systems, and ultimately we were able to fix it just by changing the way that specific ability works. Similarly, recently when we were shipping Kayn, we needed to have during his ult that he would sort of follow around the target that he had just infested. And so we borrowed a system called the follower system that Quinn's Valor uses to attach to her, or that Kled uses to attach to this rolling version of Skarl, which actually isn't the Skarl model, it's a different model. But basically, the tech debt here is that the follower system was built to attach a brand new model onto an existing model. And we repurposed it to instead attach Kane, which is a really existing model, onto another model. And so basically, there was this kind of gross hack of saying there's an invisible minion, and that invisible minion is just telling Kane, hey, by the way, this is where you are, this is where you are every frame. It's gross, but it's not going to affect anything else. So the last thing I want to talk about local debt is how do you fix it? Well, the first question is, do you need to? Oftentimes, local debt makes you feel gross. It makes you feel uncomfortable that it's there, but ultimately it doesn't really impact things. So maybe you don't need to fix it. But if you are, one of the advantages of it being contained is that you can typically do a very targeted test to verify that you have fixed it and not broken anything else because it is contained. So thinking about local debt in terms of those 5 metrics, it tends to be not hugely impactful on the product because the bugs are contained to that system. In general, it doesn't slow down dev time because most of your system isn't really impacted by it. It's not very contagious because it tends to be contained, and the fix time and risk are both relatively low because of the fact that, again, you can just think about it in isolation. So we're going to go up the chain a little bit to the next type of debt that I've identified, which is MacGyver debt. And this is basically when you have a bunch of different systems that, you know, it's most typical with 2, but maybe you have 6, that you need to put adapters between, basically. And so some actual examples of what MacGyver debt looks like in the real world. It happens a lot of times in plumbing, where you have pipes of one size, maybe coming in not where you want them, or maybe that this toilet is a little lower than your typical user wants it to be. And so you can sort of start, you know, hacking things together and ultimately getting to where it will function. A more serious example in Seattle, where I spent a lot of time living, it was actually 2 different cities with mayors that didn't like each other, and they built on slightly different grids. And so you can see that when those 2 grids actually grew into each other, you have to have all these awkward triangle blocks in order to make it work. And I particularly like the building in the bottom left that just has a little bit of its corner shaved off. And that's what MacGyver debt most often looks like. It's just 2 systems that are combating each other, and then ultimately you have to interface between them somewhere. So some examples from League of Legends. Anoop Cambodge was working on making it so that we could put particle effects on the camera in order to have like screen space things going on. And he discovered that the camera is left-handed and just about everything else in the game is right-handed. And so that means that in order to have those coordinate systems work together, there's a lot of multiply the z by -1 every time that you transfer between one or the other. And so each of them are totally valid. It's just every time you interface between them, there's a conversion. Another example is we are in the process of replacing uses of the standard library from C++'s string, which is not very memory careful, with a string, which is Franta Fulin's hand-rolled string that is much more careful with how it represents memory. And so you'll frequently have code that looks like this, which is a function that takes in a standard string and spits out an A string, just because it happened to be easier for those to be the inputs and outputs. And then down right at the bottom, you have the conversion, which is where you take the standard string and you get the underlying representation in memory, pass it into an A string, and construct the new version. So how do you fix MacGyver debt? The first and most important thing is that you halt the spread, because it can be very contagious. It can be that this system that is the one you want to replace is going to keep spreading because it just happens to be easy. So one of the ways you can do that is rename functions like this to be unsafe, do not use, or you can write RFCs, you can talk to people. There's a whole bunch of different ways, but this is a very important step, is you halt the spread to make sure that the old bad system is not getting any more deeply rooted. And then you can either do a large-scale refactor where somebody goes off and does a whole bunch of regex replacements or whatever and tries to land it all in one go, or you can convert it when changing code. And this latter I've seen a lot of success, in particular with A-string. Like it is just anytime you're writing new code that uses strings, you use A-string. Anytime you're writing code that is sort of at the interface, you just slowly creep that interface such that A-string spreads and becomes more and more like the standard for everything. So when I think about MacGyver debt, one of the things that's interesting about it is it very rarely has much of a product impact because of the fact that you can use the good system if the good system is required for your product goals. And both systems are usually on stable footing, so it tends to not have a ton of bugs that are coming out because of it. It does increase your dev time because every time you switch across that interface, you need to restructure your brain and be like, wait, how does that other system work? Oh yeah. And so it's just this like tax on how you think about things. It can be very contagious. That's why I said halting the spread is very important. But like if any engineer can pick either one or the other of the two systems, then they will be frequently spreading the bad one. It can take a reasonable amount of time to fix, but ultimately, since both systems are theoretically stable, the risk tends to be low of I'm going to fix a little bit, test that, cool. Okay, I'm going to fix a little bit more, test that, cool. So the risk tends to be pretty low. So now we're going to talk about foundational debts. This is basically when you have some underlying assumption that is like deeply baked into the fabric of how your code and how your data works. So again, let's talk about some examples from the real world. One of them is how dumb the imperial measurement system is. I don't know what a slug really actually feels like. And in particular, how many like tablespoons are in a quart? Who the fuck knows? Another example is in Europe, there are a bunch of streets that were built before cars. And thus, when you try and put cars on them, they just don't fit. And that's not something that's very easy to fix. You'd have to tear out all of these blocks in order to make them fit cars. And so people just instead deal with it and hopefully don't get stuck. Yeah. So some examples of that, again, from League of Legends. We had a free-for-all of clock systems where, if you needed a timer, you write your own timer class. Maybe you ask the system how many seconds have passed since 1970 or whatever. And it was just a free-for-all where there was no unifying system by which we could tell time in the game. I really like the way that Rick wrote this up in his tech blog about it. He said, "I won't speculate on how the code base ended up with so many implementations of clocks, but it's clear to us that we'd see some fairly major productivity gains by creating a centralized, robust, precise, and easy-to-understand time system." And ultimately, this is one of the first steps towards getting our game to be deterministic, which has paid huge dividends for game development on League of Legends since then. And ultimately, they unified on 3 different clocks that each serve a different purpose. There's the simulation clock, which is how much time has Lux seen take place in the game. The system clock, which is how much time has the player who is playing as Lux seen. So this includes things like pause. And finally, the wall clock, which is if you are trying to watch the game on LOL Esports, how much time has passed in real time so that you can figure out, schedules. Another example of foundational debt that we still certainly have is Lua scripting. In League of Legends, the scripts that are built by designers are all in the thing called Block Builder. It's a visual scripting language. It has a tool called Block Builder that lets them choose verbs like face direction, spell cast, teleport, etc. And then they choose drop-downs. They type in variable names. It's a relatively simple, constrained editing experience for code. But under the hood, it actually is raw Lua script, just not very useful raw Lua script. Ultimately, it's actually a bag of key value pairs for the most part, but just for whatever reason, somebody ages ago decided to store it in Lua. And so we're paying a bunch of the cost of having a Lua VM running on our game without getting much benefit out of it, because we could have just stored this all as like raw data. And we're constantly paying the cost of this, of our call stacks are polluted, and garbage collector will maybe crash even though we don't need a garbage collector. There's no reason we should be running a garbage collector on this stuff. And so this is some tech debt that we very actively are paying a ton of cost for and hopefully will replace at some point. And there are various proposals on how to replace it. So how do you fix foundational debt? The most common way that I have seen is that you stand up your better system and then you make some MacGyver debt out of it. And like, it's possible that you can do like a holistic, like here's the one thing, and then you pull the tablecloth out and hopefully keep all the dishes on top of it. But this system I've seen be much more successful of like bite off a little chunk and like steadily convert over to your other system. When I think about foundational debt, it is certainly very costly in terms of the contagion, the fixed time, and the fixed risk, because it's baked into everything about how your code works. It's baked into all of the underlying assumptions, and so you're going to have to touch a huge swath of code. There's a high risk to any of those changes, and that's why I recommend converting to MacGyver debt, so that you can get the fixed time and the fixed risk like sort of contained and try and stop the spreading of the contagion. I will say it tends to not have as high of a product impact as one might think, or a dev time impact, because it's just sort of baked into the way everyone does things. It'll be an assumption about how, say, League of Legends is made, that we just have to deal with the fact that it's in Lua. And so you don't really see a huge cost. You might see a big benefit of switching, but it's just sort of baked into all your assumptions. So now we're going to talk about my least favorite type of tech debt, which is data debt. Imagine you're traveling around Europe and you rented this car, and then you realize you have way too much stuff, and you just try and pile more and more stuff onto that car. And then you're driving up towards a border checkpoint, and you're like, oh shit, where'd we put our passports? Got to get through. And then you meet a friend in Brussels, and you're like, and he asks if he can come right along with you over to Amsterdam, and you try and find a spot in your car. Like, data debt is where things are just piled on top, and it just makes everything harder to do because of whatever assumptions caused that data to be built. So some real world examples include DNA. The way that DNA works is relatively well understood, but there's all kinds of copy errors, and there's all kinds of like duplications that make it very difficult when we look at the like billions of base pairs to tell which parts actually matter and which parts don't. And so when we're actually trying to understand like the cause of a disease, for example, we just have to do like pattern matching between people who do and do not have the disease, and then try and reason about, okay, so apparently these base pairs matter in order to try and understand it, just because there's just so much fucking data encapsulated in it. Another example is the English language. I love this rendition of potato. For those trying to read it, it is the P from hiccup, the O from donut, the T from Phthyisis, P-H-T-H-I-S-I-S, who knows, the A from neighbor, the T from gazette, and the O from plateau. But yeah, like English language has just this enormous amount of, quote, rules baked into it that many of them are contradictory, which makes it incredibly difficult to learn the language or do anything in it. So what makes data different? And many of you might think, do I have data? Some people just write code all the time. Well, data is whatever it is that you work with that is less structured than code. Typically, you don't compile it. It is just something living on a disk somewhere. It tends to be more copy-pasted. If somebody is trying to produce another spell in League of Legends, they always start with one that already exists that mostly works. And so if there are any bad things in that existing spell, they will copy-paste it and keep all of those bad things and just keep adding more bad things on top of it. And finally, the process by which data tends to be produced is non-rigorous. If you are adding new code anywhere at the company, I am assuming you're doing code reviews of some sort, whereas we don't do that type of thing with data. And so if you think about, do you have anything that is like this in your day-to-day work that is like non-rigorous, copy-pasted, like just accumulates in piles? That's what I mean by data. From League of Legends, some of the scope for data, we have C++, that is the code that we write for the game. We have, around 1 million lines of code in the engine and game layers spread out across about 5,000 files. Lua, which is what the scripts are, that block builder that I mentioned, is similar in order of magnitude, like some fewer lines of code, more files. Ultimately, it's pretty comparable. But when we talk about things like particles that are inexplicably edited in syrup, which I don't know how that's syrup, we would have 200,000 emitters shipped in League of Legends with about 5 million properties. That is, some like size equals 25 and color equals this RGB value, and spawn rate is whatever, spread out across 30,000 files. And so if I want to change something about how one of those properties works, I have a big question in my mind of what's going to break as a result. And what's worse is, in order to verify that I didn't break something, I need to look at it with my human eyes in-game and subjectively figure out whether I broke that effect. It's horrible. And then we're replacing various different types of data with a somewhat more structured thing, game data server using JSON. So it's more structured, it's easier to reason about, but the type, like the quantity that we're dealing with is still enormous. Again, about 5 million properties spread out across, in this case, 40,000 files. So again, anytime I'm making a change that may affect the way that this data works, I need to start thinking about a lot of different cases. So some examples of what should be relatively easy code fixes that are made worse by data debt include, we had parameter assumption that was fixed. This was fixed a couple of years ago. But it was a thing in Block Builder. So here is a Block Builder, some code where we would set the variable delta to 20. And then we would attempt to add armor to the owner. And anyone have any guesses how much armor the owner would get from this block before the fix? James.
I'm going to say 25.
That's a good guess. Paradoxically and confusingly, this one you'd actually get 20. Because if it found something if it found something from assuming the variable name and just checking the local variable space for that variable name, that would just win for some reason. In this case, instead, we manually passed delta in to the variable. What do people think this might give you? Come on, just shout out a number. I heard a 40. That's a 40, yes. So we would find that you had passed in the variable and then also notice, hey, look, there's a local variable that's called that thing. Set them together. Perfect. And then here we've renamed delta to its cousin delta. What do we think the variable is going to give us this time? 25. This is the one that is actually doing what we claim it is doing. So this was fixed by Anoop in 2015. But it took like months of talking about this 3-line code fix of removing that assumption. We had to think about, we had to like do regex searching in order to try to figure out what's going to break because we do this. What's particularly funny about this example is I tricked myself when I made this because inc stat is very specifically implemented in a different way that is not affected by this bug. So that's just sort of more of how it is hard to reason about data, basically. Another example of data debt making a simple code fix very difficult to do is vector defaulting. If in Lua you ask for a vec3 and you don't actually have one and you didn't pass it in as a variable, then it would default to 0, 0, 0. Unlike any other data type, for whatever reason, the vec3 did not emit an error when this occurred, and thus the script would carry on as if 0, 0, 0 was really what you had passed in. And this, we speculate, is the cause of a whole bunch of interesting bugs like this, where I believe Lee Sin teleports to 0, 0, 0 for a frame, and thus he moved across all of that space from where he was and to the origin, and Blitzcrank Hook grabs him. And this was one I fixed relatively recently, and I did it very trepidatiously because who knows what's going to all of a sudden break because now we're emitting errors when you don't actually pass in a vec3. So how do you fix data debt? One of the ways that you can do it is you can add a do it right checkbox. So if every access to vec3s had a checkbox that says, do you want to error or do you want to use 0, 0, 0, then that's a way to sort of contain your fix. But then it just adds more data debt on top of all of these checkboxes that are like, oh yeah, I want to do it right here. I don't want to do it right there. So I hate that, but it is a way you can do it. The other way is you can script and grep across all of your data, try to understand what the scope of the problem is, fix it, do a ton of testing that is informed by that scripting and grepping to figure out what actually needs to be tested. And most importantly, you prepare a toggle before you ship it to players because you are not going to test everything. And maybe the thing that you didn't test is actually way worse than the original bug. And so I've seen this pay off many times where you have a toggle that you can say, okay, no, reintroduce the bug that we were trying to fix because it is the less bad bug. So one of the interesting things about data debt is its impact on the product tends to be very varied, whether it is causing like lots of bugs or little bugs. It's hard to know, but it always has this huge cost to dev time. I've been talking about a couple of examples of 3-line code fixes that take weeks to do. That's my life. Like when I'm developing for Champions Team, I'm thinking about data debt all the time and it slows everything down. It's extremely contagious because you copy and paste these things all over the place. The fixed time can be writing 3 lines of code. It can be re-architecting an entire system, so that varies wildly. But you always have this huge risk because your data typically needs to be understood subjectively instead of objectively, and it's very difficult to test. So again, what I talked about here is I talked about some metrics to evaluate your tech debt. You have product impact, dev speed impact, contagion, fixed time, and fixed risk. There's 4 broad categories of tech debt. We have local debt, MacGyver debt, foundational debt, and data debt. And hopefully you kind of agree with me at least a little bit that data debt might be the worst.